Today we are going to look at vertex form and graph from vertex form. The vertex form of a quadratic function is given by f of x equals a of x minus h squared plus k, where h and k is the vertex of the parabola. H is the opposite. Okay, so h is the opposite. I always call it negative h, okay, because it's the opposite. And h is our axis of symmetry. And k also is our max or min. Is y equals k. And the h represents the horizontal shift. The k represents the vertical shift. Essentially, it's your vertex, okay? And h and k is our vertex. Okay. So down here, just like in this example, it says that the h is 1, the k is 5, or 1, 5 is the vertex. Also, if the a is negative, the parent graph flips. If greater than 1 or less than negative 1, the parent graph stretches vertically. We call it get skinny. If between negative 1 and 1, stretches horizontally or gets fatter. So to graph this one, we need to jot down a few things. The vertex is negative 2, 5. The direction is this way because it is positive. No, the direction is a frowny face because it's negative. It flips. Okay. The axis of symmetry is x equals negative 2. There is a max at y equals 5. And this stretches horizontally or gets fatter. So we can graph this. First, I'm going to graph my parent graph in red. This is the parent graph. Okay, this is where everything comes from. Okay, now I've got to graph the other one, and I'm going to graph that in black. Okay, we're just going to graph a sketch of this. So we go to negative 2, 5. 1, 2, 3, 4, 5. And then it goes down. First, I'm going to sketch a parent graph going down, which is just 1, 1. 4. Okay, but my graph I'm sketching in black gets fatter than that, so we just sketch it out. Boom. Sketched out. And that black graph is our graph of this. It's just a sketch. All we're doing is sketching them today. Okay, we'll do one more. Okay, we are going to first look at this one. Our vertex is negative 2, negative 3. That's our vertex. Our axis of symmetry is x equals negative 2. It opens down because it's negative, therefore it has a max. And the max would be y equals -3. We go to graph this. First, I'm going to graph again the parent graph. And again, that's just 1, 1, 2, 1, 1. Okay, 1 squared times 1 squared is 1, 2 squared is 4. That's why we step 4 on the second one. Okay, that again is the parent graph. Okay, we're going to graph the other graph in black. Okay, first we have to graph the vertex, which is -2, -3. Then that again opens down. Okay, and it is the same. Okay, it doesn't stretch either way, so therefore we can just graph the parent graph from there, which is 1, 1, 2, 4. And then boom. And that is the graph in black. One other thing we have to do is be able to put things back into standard form. Our standard form was ax squared plus bx plus c. So we have to get that back in that form. So on f of x equals 4 times x minus 1 squared plus 9, we would need to FOIL x minus 1 and then add 9. Okay, when you FOIL that, you end up with 4x squared minus x, and then -1 times -1 is +1, plus 9. Distribute the 4, and you end up with 4x squared minus 4. Oh, this ends up canceling to -2x, so it'd be minus 8x plus 4 plus 9. Add up our like term at the end there, and we would have it in our standard form. 4x squared minus 8x plus 13. And that's how you get things back into standard form.